In this video, we're going to look at asymptotes of rational functions. So there are three types of asymptotes: vertical asymptotes, horizontal asymptotes, and oblique asymptotes. Let's talk about a definition. Vertical asymptotes. A function r of x has a vertical asymptote at x equals a if the limit when x goes to a from either the positive or the negative side of f of x is equal to either positive or a negative infinity. So I wanted to show you a picture because sometimes that makes more sense. And in this picture, you can see that if we approach -1 from the positive side, which is the red part of this picture, it's going up toward positive infinity. Or if you look at what happens when x goes to -1 from the left side, which is in blue, then we're approaching negative infinity. So as we're coming close to this line, that is the vertical x equals -1, we see the split in the graph and it's going to infinity. Okay, important note here too, see how the function is coming toward the vertical asymptote? It's never going to actually touch it and it's never going to cross it. So this is an issue with domain. So remember we talked about continuity before. So it's not continuous at -1, but it's coming to -1. So we need to talk about the steps to find vertical asymptotes. So the first step we should do is try to factor the numerator and the denominator of f of x. The reason we do that is we want to cancel any common terms if they exist. And then in step 3, we're going to set the denominator equal to 0. Let's take a few examples to make sure we're ready before we move on. So let's look at this one. I have f of x is 3 over x squared minus 16. So I'm going to start by factoring this. So I have 3 over x plus 4x minus 4. I see there's nothing in common from the top to the bottom, so I just grab the bottom and I set it equal to 0. This tells me from x plus 4 that we get -4, and from x minus 4 I get +4. So I have two vertical asymptotes for this function. Let's try it again. This time I have x squared minus x minus 12 over x squared plus 5x plus 6. So I want to start by factoring. At the top I'm looking at -12 that gives me -1, so that's going to be x minus 4 and x plus 3. In the bottom, I need factors of 6 that add up to 5, which is going to be x plus 3 and x plus 2. So I can see in this particular one, I have a common factor, x plus 3, in the numerator and denominator that I'm going to want to get rid of. So it leaves me with x minus 4 over x plus 2. So I only want to take that x plus 2 and set it equal to 0, which gives me -2. Now that 3 that I threw away isn't completely gone. I kind of have it in my head. I'm going to write myself this note that x equals -3 is not in the domain. It's a hole in the graph. So let's talk about our next type of asymptote, which is a horizontal asymptote. And again, let's talk about when does it occur and why. So r of x has a horizontal asymptote at y equals b. If when I take the limit as x goes to infinity, and that could be positive or a negative infinity, so I should have written that in there. So when I go to infinity of r of x, I get b. So you should think of horizontal asymptotes as the end behavior. That's why it goes to infinity. Finding the horizontal asymptotes is the same process we use to find the limits at infinity of rational functions at the beginning of the semester. So hopefully it won't seem like a whole bunch more stuff to learn because it really wasn't long ago that we did it. So back when we talked about limits, we talked about rational functions, and I gave you this definition that r of x is a sub n x to the n plus a sub n minus 1 x to the n minus 1. And it kept going until we got to a1x plus a naught. And then in the denominator, I had b sub m as x to the m plus b sub m minus 1, x to the m minus 1, blah, 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 until I got b1x plus b naught. Remember here, the a's and b's are real numbers, so they can be anything. They can be positive, negative, fractions, decimals, whatever. The only restriction is that the first one, a sub n is not 0 and b sub m is not 0. I have to have something there to start. N and m are whole numbers, which means they could be zeros. I could have some exponents that are 0. I don't have to have all the terms. But I can't have negatives. I can't have fractions, stuff like that. So I have to have something there. Okay. So let's talk about when do we have a horizontal asymptote. And there are 3 cases. So here's the first one. R of x is going to have a horizontal asymptote at a sub n over b sub m if n equals m. So when the degrees of the numerator and the denominator are equal, then we're just going to take the leading coefficients of each and we're going to make a fraction. R of x is going to have a horizontal asymptote at 0 if n is less than m. So here, when the denominator is bigger than the numerator, then the asymptote is going to be at 0. And then the last case, there's no horizontal asymptote if the numerator is a higher degree than the denominator. So when they're equal, I do leading coefficients. When the bottom's bigger, it's 0. When the top is bigger, there's none. All right, again, let's look at a picture. This graph has a horizontal asymptote at y equals 3, pretty easy to see. Notice that the function approaches 3 as I'm going toward positive infinity on the right and negative infinity on the left, but this is an end behavior kind of thing. The points I get in the middle doesn't really matter. When I'm looking at the asymptotes, I'm looking at the end. So because what happens in the middle doesn't matter, I wanted to show you a graph like this that also has this asymptote at 3. A little harder to see because I kind of zoomed out. What I wanted you to see in this picture is that the function does cross the asymptote, and that's perfectly okay. You can cross a horizontal asymptote, not a vertical. So sometimes that will happen because horizontal is only end behavior. It doesn't tell me what's going on in the middle. So a third type of asymptote that may be new to a lot of you is called an oblique asymptote. Okay, so again, let's walk through what does that mean. So R of x has an oblique asymptote at y equals mx plus b, so not just b, but mx plus b, if the limit as x goes to infinity, and again, this is plus or minus, of R of x is mx plus b. Okay. Remember, we have this equation, right? This is what our rational function looks like. So when this happens is when the degree of the numerator is exactly 1 greater than the degree of the denominator. So see how here I said n equals n plus 1, and then here I push the word exactly. If it's 2 greater, there's not 1. If they're equal, there's not 1. So it has to be just 1 bigger on the top than it is on the bottom, then I get an oblique. And I want to show you what it looks like. So do you see the oblique just means it has a slant? But again, it is showing me in behavior. See how our function is going along that dotted red line. So you could kind of picture, really, I would have 2 lines going on in here. And let's see if I can go ahead and put it in for you. Let's put it in a different color. So I would have a vertical coming through here. Right? So we would find our vertical. And then we find in our oblique, and we can see that we're just kind of filling our function in to follow those 2 asymptotes, which is the purpose we have them. They're giving us guidelines. They're going to make graphing easier for us. All right, so what we need to do is get through, well, how do we find the oblique? So let's start with this example. I have x squared plus 3x plus 5 over x plus 4. So definitely we know there's an oblique asymptote here because the numerator is 1 degree higher than the denominator. But the trick is we need to do division. So we need to divide x plus 4 into x squared plus 3x plus 5. So again, I'm going to write on here for you. It doesn't come out great, but it'll be okay. So I'm going to have x plus 4 and we're going to divide into the x squared plus 3x plus 5. Okay. So don't overthink it. You really want to start with how many times does x go into x squared? So you know x goes into x squared x times. So I'm just going to put the x up here. It doesn't really matter where, just put it up there. Then I need to say x times x is x squared. Then you need to say x times 4 is 4x. So I have a plus 4x. So it's really important, after you do this first division, x into x squared, to get x, to say how I should start, you need to multiply the x times the x and the x times the 4. Then when you're subtracting, you want to remember to subtract both of these terms, so pay attention to the sign. The x squared cancels the x squared. If you do it right, that should always happen. Then I have 3 minus 4, which is negative x. Really important that the sign matches here. Okay, so I have to pay attention to the sign so that I don't mess it up and get the wrong oblique. Okay. Now I look at what's x into negative x. So negative x over x would be negative 1. I do negative 1 times x is negative x. I do negative 1 times 4, it's negative 4. Again, we're subtracting, which really isn't important this time. I have 5 minus negative 4 is 9. We get to throw away remainders. Remember, I was looking for an mx plus b, and here I have it. So this, let me just pick a different color. This x minus 1 up here, this is my answer. So let's write it. My oblique asymptote is y equals x minus 1. Okay. Let's go through a little reminder about graphing lines. Remember when we use this equation y equals mx plus b? B is the y-intercept, and I messed that one up. That's supposed to be an m, but we're going to fix it right now. Alright, so here, this should say, remember when using the equation y equals mx plus b, b is the y-intercept and m is the slope. We should always start by graphing at b. So in this one, we had y equals x minus 1, so we want to start at negative 1. And I want to start in a color that hopefully will show up, so let's try this. So here, right here, and I'm going to try to make it big enough so you can see, is a negative 1. All right, then we want to use the slope. So our slope, because we have x minus 1, coefficient of x is 1. But if you need to turn that into a fraction so it makes sense, 1 is 1 over 1. So I want to go 1 up and 1 over, and there's another point. Okay. Then I have that, then this is my oblique. I am going to dash this just because asymptotes are usually dashed. And you guys know how well I draw, so it is a little crooked, worse because I'm doing it on a computer. But it does give you that general idea. We will do these plenty in class too, but I want you to see what it looks like. Alright, so let's just find some asymptotes. No drawing involved, just asymptotes to see what things are going on. So let's start with this one. F of x is 3x minus 5 over 2x plus 4. So start with vertical. Vertical says grab the denominator, 2x plus 4, set it equal to 0. So you can see I push the 4 over, it becomes negative. I divided by 2, I got negative 2. There's my vertical asymptote. As far as horizontal goes, I have a 3x on top, 2x on bottom, so the degrees are equal. I just grab the 3 and the 2, and I have y equals 3 over 2. That's my horizontal. I do not have an oblique because the degrees are the same. I never have a horizontal and an oblique at the same time. I can have one or the other or neither, but I'll never have both. So as soon as I get a horizontal, I know there's no oblique. So let's check out this other one. B is f of x is 2 over x squared minus 8x plus 7. For the vertical, I have x squared minus 8x plus 7. I want to set that equal to 0, so I think we'll better factor it. So I factored into x minus 7, x minus 1, which gave me x equals 7 and x equals 1. For the horizontal, I can see the denominator is bigger than the numerator, so that tells me I have a horizontal asymptote at 0. And like we just said, because I have a horizontal, I do not have an oblique. Okay. So let's look again. Let's find all asymptotes. I have x cubed minus x over x squared plus 5x. Now at this one, I should start by factoring because I can. In the last couple, there's nothing to factor on the top, so there was no reason to go through factoring. But this one, I can factor on the top, so we should do that. So the first thing I'm going to take out, I just noticed they both have an x in common. So I can turn the numerator into x squared minus 1 over x times x. And then denominator, I can make that x plus 5 times x. I have this x factor in common that I want to get rid of. So I'm going to cancel it out and just, again, make myself a note that x equals 0 is not in the domain of the function. Okay. Now I can look at the vertical asymptote, but I'm only looking at x plus 5 equals 0, which gives me x equals negative 5. The horizontal asymptote, degree of the numerator, and it doesn't matter if you go back to the beginning and say it was 3 over 2, or if you go to our reduced form and say it's 2 over 1, what we notice is the top is bigger, which says no horizontal asymptote. But this does say, hey, we have no horizontal, maybe we have an oblique. And we do. To get the oblique, we're going to need to divide x plus 5 into x squared minus 1. So again, I'm going to write on here for you. Okay, so I'm going to write my x plus 5 over here. Oh, it's a really ugly 5, but we'll go with it. All right, and I have x squared minus 1. All right, so I start the same way. I say x goes into x squared x times. X times x is x squared. X times 5 is 5x. Right. I like to put parentheses around this before I subtract. It just makes me really think about the fact that the signs are going to change. So the x squareds are going to cancel. See how I have this negative 5x? I need to keep it. And then I'm going to bring the negative 1 down. Notice I did not combine the 1 and the 5 because they're not like terms. The 1 is a number, it's a constant. The 5x has a variable in it, so you don't put those together. You just kind of write them side by side. Once again, I do the same thing. I say x goes into negative 5x, and that will be minus 5 times. You could stop if you wanted because we do have our line here, or if it makes you feel better to keep going, we can keep going. So I do negative 5 times x is negative 5x. And then I do negative 5 times 5 is minus 25. And once again, if we're going to go this far, we might as well put parentheses around it. So here I have negative 1 minus negative 25, which would be positive 24. It doesn't really matter. You're going to throw that away anyway. And you're going to keep the x minus 5. This is my oblique. So let's write it over here so we can see it. Oblique asymptote. Y equals x minus 5. And I'm just going to kind of square it off so it doesn't get lost. Alright, so let's look at a couple more. Number 4 says f of x is x minus 3 over x squared plus 4. So let's start with vertical, and notice that there's none this time. X squared plus 4, if you try to set it equal to 0, you cannot solve for it in the real number system. So x squared is positive, 4 makes it bigger, I don't have a vertical. Horizontal, the degree on the bottom is 2, degree on the numerator is 1, so I have a bigger bottom, which says it's 0. Because I have a horizontal, immediately no oblique. Hopefully you can notice I wasn't being too clever here. All I did is turn this over. So instead of x minus 3 over x squared plus 4, it just became x squared plus 4 over x minus 3. So again, I'm starting with the vertical, which says grab the denominator x minus 3, set it equal to 0, so I get x is 3. When I go to look at horizontal, the degree of the numerator is bigger, so I know that I don't have a horizontal. But I am back to that step if I have an oblique. So the oblique, again, let's go ahead and do some division. I want to say x minus 3 goes into x squared plus 4. And this is a lot like the last one we had. Okay. So x into x squared is x. I multiply, I get x squared minus 3x. Okay. So I like to put my parentheses around it before I do my subtraction. These x squareds are canceling. Then the 4 I can keep. Minus negative 3x is bring down a positive 3x. And then say plus 4. Okay. X goes into 3x 3 times. So I have 3 times x is 3x. I have 3 times 3 is 9. Again, my parentheses before I do my subtraction. The 3 x's will cancel. I'll end up with a 13 that I just throw away anyway. So my oblique asymptote, let's write it over here, y equals x plus 3.